Okay, guys, here we are with sections 2.7. We're towards the end of the chapter here on combining functions. And I think you did this in Algebra 2. I'm not positive. Hopefully you did. We're just going to look at combining functions by adding, subtracting, multiplying, and dividing first off. And then we'll talk about the compositions where you actually do some substituting in. Okay? So a basic example here would be when we have two functions. We have a square function, a quadratic, and then a square root function, and I need to find what happens when we add them, subtract them, multiply and divide them, and particularly their domains. So this is simple. If I want to add the two functions together, okay, basically you just write x squared plus the square root of 3x. Now let's talk about domain here for these problems. My domain, when I'm checking domain, I have to make sure I'm looking at both of the functions. So the domain for the f function is all reals, but my domain for the g function would be greater than 0. So I need to include that greater than or equal to 0, actually, in my final answer. Okay. Now when I'm subtracting them, again, now if you can simplify your function in the homework tonight, please make sure you do that. But here we don't want to worry about simplifying, okay? And again, that domain would be the same thing. If we can multiply the two functions together and simplify that, we would do so. Here we can just leave it as x squared times the square root of 3x, same domain. And we have a slight change when we're dividing in my domain. If I'm doing f divided by g, it's going to be x squared over the square root of 3x. And the only difference here with this domain is that I cannot have 0 in the denominator. So I need an open interval for 0 on the left side. Okay? Now, if I'm asking you to evaluate or find f plus g, again, some of this is just notation for some of you. Here's what we're going to do. We're going to take the function that when we added and substitute in 3. Okay? So my addition formula was to do 3 squared or x squared plus the square root of 3 times 3. Substituting in this 3 here. And that's basically going to be 9 plus the square root of 9, which is 3, or 9 plus 3 is 12. Okay, so we can either take those pieces apart and plug them in separately, or we can take whatever you get when you simplify with your addition and subtraction and then evaluate it afterwards. It really doesn't matter. Okay, so that's basic. Just make sure you check on the domains for those problems. Okay, all right, the composition of functions is what we do when we substitute. Now, there's a couple different ways you're going to take a look at this. Sometimes you'll see it written like this, which means f of g of x. Sometimes you see it with this little f of g symbol there, okay, or even, f of g of x. And really what it just means is that you take the g function and you substitute it into the f function, okay? So substitute g function into the f function, okay? All right, now I have some good examples here for us to take a look at, and take note of my color here, okay? The f function is orange, my green function is green, and the h function is blue. Okay, so if I want to find f of g of 8, the first thing I need to do is evaluate for g of 8. Okay, we do what's in the innermost parentheses first, so my green function would be g of 8 is going to equal 3. Okay, 8 minus 5 is 3. Now I take that 3 and I plug it into my f function. So I basically want to do f of 3. So f of 3 is going to equal 3 squared, or 9. So f of g of 8 equals 9. Okay? Now, do you think g of f of 8 will give us the same result? Sometimes it does, sometimes it doesn't. Okay, clearly here, when we even just start off the problem, we can see that f of 8 is going to be 64. Okay, and now I plug that into my g function, so g of 64 is going to equal 59. 64 minus 5, or 59, okay? All right, now what if we want to do that evaluating, or not evaluating, we want to do it for all possible values of x, okay? So these next three examples are all similar, but completely different outputs. So it says find f of g of x. So again, if I'm going to write this out, I'm going to write f of g, the g function. My g function is x minus 5, okay? So I'm going to take that g function and fill it into the f function. And the f function says to square whatever your input is, okay? So my result would then be x squared minus 10x plus 25, okay? Domain for that. Now, for these problems, you have to worry about your domain for your input value as well. And since that's a linear function, my domain is all reals, and also my output, which is the quadratic. So this domain is easy. It's just all reals, okay? So negative infinity to infinity. Okay, let's try h of g of x and then find that domain. So this time I'm going to take my blue function and substitute in the x minus 5, or the green function, into the blue function. Okay, so here's what happens when we do that. We're going to have the square root of 4 minus my input, which is x minus 5, or the green function. Okay, simplifying that, we've got the square root of, what's this going to be? 9 minus x. Okay? So once again, my original domain was linear, right here, x minus 5. But when I look at my output, I have to take note that the 9 minus x has to be positive, greater than or equal to 0. So when I'm solving for x here, I get x is less than or equal to 9. Let me scroll down a little here. So this domain is going to be negative infinity to 9 inclusive. Okay, that's that domain up there. Now, you can also substitute a function back into itself as well, and that's what we're doing in the last statement here. Find h of x, and then its domain. Now, this domain is a little bit trickier to do. So what we want to do is take the blue function and plug it back into itself again. So let me distinguish here between the colors again. So this blue function was 4 minus x, or square root of 4 minus x. Okay, so this is going to look a little strange. So we want to take the square root of 4 minus x and plug it back into the square root of 4 minus x again. Okay? Now we can't really simplify that at all, but let's think about what this domain would be. So first off, we have to look at the original input. That domain, we know, has to be positive. Okay? So we have x is less than or equal to 4 for that problem. But we also know in my output, look at this, that this also has to be positive. That value under that radical needs to be positive as well. Okay, now be careful solving this. We're going to end up with 4 is greater than or equal to square root of 4 minus x. Okay, if we square both sides, we'll get 16 greater than or equal to 4 minus x. We can subtract subtract 4, and that will give us 12 greater than or equal to negative x. And of course, we have to solve for positive x. We flip the inequality sign, and we have x is greater than or equal to 12. So the domain for this problem, we have to include both restrictions there, whereas x is less than or equal to 4, but also greater than or equal to negative 12. So in interval notation, We've got that. Okay? All right, so composition on function basically is substituting in. Now this next problem, we're going to look at the composition graphically. Okay, so let's see if you can follow along here. Just watch what I'm doing on the board. We have an f function, which is a quadratic, opening down. We want to compute f of f when x equals -1. Now, I'm just going to look at this graphically, and then we'll look at it algebraically as well, okay? So what is f of -1, basically? Let me write that down for you. F of -1. I don't know if you guys can see this whole thing. Let me scroll. This thing is in my way. All right. So let's go to the graph. And what is f of -1? Here's f of -1 right here at +1. So if this coordinate is -1, 1, then f of -1 equals, let me write this up here, equals +1. So now I want to figure out what f of 1 is. Okay? And f of +1 also equals 1. So f of -1 would just give us 1. Okay? How about f of 0? Let's look at that one. Let's do that here. f of 0. So when the input is 0, my output is 2. At 0, we're up here at 2. And now I want to figure out what f of 2 is. F of 2's y coordinate or output would equal -2. So f of 0 would equal -2. Okay? So you might have some visual problems like that in the homework. If we take two different functions, oh good, I have them up here from before. If we have two functions here, 1 minus x squared and x squared plus 0.5x minus 1, we know what's going to happen when we add those together, okay? I think in the homework they might ask you to graphically add things. So if you can visualize what's going to happen here, the x squared terms cancel out, and we will have a linear term, okay, 1/2 x plus 1. That will give you a line, obviously, okay? But I want to show you here, I did this ahead of time. On your calculator, when I typed in 1 minus x squared, that's that parabola facing downwards. So this is my y1 right here. Y2 is the parabola facing upwards. And then when I added the two functions together, notice on the calculator I just did y1 plus y2. That gave me the linear function, the line, okay? And if we, again, take those two functions and add them together, x squared plus 1/2 x minus 1, the x squared terms cancel out, and we're left with 1/2 x, just 1/2 x, okay? And we can see that it's going through the origin, so our slope is 1/2, y-intercept is 0, okay? All right, let me stop this because I'm getting a little tight on time. I only have two other problems to show you, but I need to make sure I have enough time for them. So let me pause this.